Okay, so where we left off last time, I was talking about the average velocity, which is going to be the final plus the initial, all divided by 2. So that'll give you the average point, which will be halfway between u and v. And then you multiply that by t, and that'll give you the displacement. So that's another equation. This one's quite an interesting one. I'd forgotten how to derive this for a while, but then I remembered in our last lesson. And it's basically basically imagining something falling. In fact, to be honest with you, let's do this one again. And so we can say that. Oops. Okay, hang on a second. 1 second. All right, so yeah, I won't do it again. Actually, I'll just look at this. So if we imagine that something falling has got gravitational energy and kinetic energy, then no, we'll do it again. I'm going to do it with force this time. So with work, we know that work done is equal to force times distance. Now, if I had an object moving along at an initial speed of u, and then I applied a force on it over a particular distance, let's imagine over distance s actually, let's say s. And we also know that, by the way, that F is equal to ma, so the work is in fact going to be equal to ma multiplied by the displacement. Okay, with me so far? Eventually, after applying a force over that particular distance, we're going to have a new velocity v. Now, in terms of the actual kinetic energy, we can say initially we have half times the mass times u squared, and we're going to apply some work to it, which we said was equal to m times a times the displacement. That will equal to the final kinetic energy. So we've got the initial kinetic energy plus the work I've added to it. Will be equal to the final kinetic energy, half mv squared. What we do is we cancel out the m's. Whoops. We rearrange it. So we got half u squared. What I'm going to do, I'm going to do the other way around. I'm going to say AS is equal to half multiplied by v squared minus u squared. And then I'm going to multiply both sides by 2. And we'll have 2as is equal to v squared minus u squared. If you flip it around, you get, or you flip it around slightly and rearrange it, you got v squared is equal to u squared plus 2as. I've written that. It's the same thing. It's slightly rearranged. We did it in terms of gravitational and kinetic energy, but the same thing can be. It's pretty much the same thing. Then it's just a matter of applying these equations to specific situations. I'm just going to look at the time. We've got about a minute left, minute and a half. So then it's just thinking about which equation do we apply, and it's not the subject that we're interested in. What we're interested in is the missing variable. So if the question doesn't have a in it, as in we don't want it and we don't have that data, then we use the third equation. However, it might be asking us to calculate time, so we would use the third equation and then rearrange it. So it doesn't matter if they're asking you for displacement or not. The point is, what does it not have in the data, and what do we not need? That's the thing that we need to be asking to decide which equation to use. As you can see, we've got 3 of these, where S is the subject, and the remaining 2 have got V as a subject. So it's not about that. It's about what is the value that we need. Okay, so we're going to do some practice of that now. I'll stop the video there before it cuts me off. Okay.